Today, our topic is on statistical inference. Recall lang natin yung definition ng statistics. It is the science that deals with the collection, organization, presentation, analysis, and interpretation of data. For the previous quarter, natry na ninyo kung paano mag-collect ng data. So you had your surveys, nagkaroon din kayo ng mga data gatherings. You also organize your data using tables. Then nag-present kayo using graphs. Lahat ng ito prerequisite to a bigger picture in the study of statistics, which is the statistical inference. Basically, andito yung bulk ng analysis and interpretation of data natin. Pero ano nga ba ang statistical inference? This is consists of methods by which one makes inferences or generalizations about a population. Essentially, statistical inference is kukuha tayo ng sample from the population and whatever attribute or whatever man na makompute nating statistic from the sample, yun ang gagamitin natin to generalize sa ating population. So let's say nag-sample tayo ng 30 students in IRC and we found out na ang kanilang mean height is 160 centimeters. Then we will generalize that the mean height of all the students in IRC is 160 centimeters. Kahit na hindi naman natin mineasure yung height ng buong population natin. In doing statistical inference, there are two general assumptions, randomization and normality. Pero, meron pang ibang assumptions na dapat nating i-check depende kung anong inference yung gusto nating gawin. So first assumption is on randomization. The samples must be randomly selected. Meaning, ang mga sampling methods na pwede natin gamitin ay yung mga probability sampling lang. Like simple random sampling, systematic sampling, stratified sampling, and cluster sampling. Hindi pwede dito yung mga non-random sampling like snowballing, convenience, quota, purposive. The second assumption is that the population must be normally or approximately normally distributed. Meron tayong pang-check dito which is the Shapiro-Wilk test para malaman natin kung normal ba yung distribution ng ating population. However, in some cases, if it is not normally distributed, our sample should be greater than or equal to 30 to satisfy this assumption. So what are the areas of statistical inference? We have two, the estimation and the test of significance. Estimation is the process of approximating the value of a parameter from information obtained from a sample. So let's say kukuha ka ng mean ng sample mo, yun ang gagamitin mo to estimate the mean of the population. Or kukuha ka ng sample proportion mo, yun ang gagamitin mo to estimate the proportion on the population. While a test of significance is the process of assessing the evidence provided by the data in favor of some claim about the population parameter. Ito naman, tulad doon sa experimentation ninyo, meron kang data values na magagather and then you compare them and doon mo makikita kung may significant difference ba sila. At saka ka magko-conclude about the population. In a study examining high schoolers' readiness for remote learning, a researcher randomly sampled 150 individuals from the population and found that 38% of these individuals claimed to be ready for remote learning. This is an example of estimation kasi from the random sample, na-find out niya na 38% of these individuals are ready for remote learning. Example number 2. According to a survey conducted by the Social Weather Station, 44% of adult Filipinos express optimism, stating that they believe their quality of life will improve over the next 12 months. This is also an example of estimation. Na-estimate lang natin yung proportion of adult Filipinos na optimistic. The average annual salary for a civil engineer in the Philippines is reported to be 260,043 pesos, according to the data from PayScale. Average ito per annum, so this is an example of estimation. According to an SWS survey conducted in May 2005, 53% of all adult Filipinos participated in at least one form of gambling activity within the 12 months preceding the survey, as reported by Business World Online. Again, this is an example of an estimation. A teacher aims to identify the most successful teaching method within blended learning. To do so, the teacher divided the class into three groups and implemented three different approaches. One is synchronous class discussions, two is pre-recorded video lessons, and three, printed modules. The teacher utilized pre-tests and post-tests to assess and compare the average gain scores of the three groups. So this is an example of a test of significance. Kasi meron siyang tatlong treatments and then nagpa-pre-test and post-test siya. Sa kanya i-compare ngayon, alin sa tatlong ito ang may pinakamataas na gain scores. The average weekly internet usage for the general population is reported as 18.3 hours. A researcher conducted a study involving a random sample of 48 teenagers, finding that their mean internet usage per week was 20.9 hours. The researcher aims to determine if this mean time significantly differs from the reported population average, with a significant level set at 0.01. So again, this is an example of a test of significance kasi merong reported na mean weekly internet usage na 18.3 hours and then yung researcher, nakita niya na yung mean internet usage per week ng 48 samples niya is 20.9. And they want to know kung magkaiba ba talaga ito or baka same lang naman pala. A researcher sought to investigate whether millennials exhibit preferences among various types of music. They collected data from a sample of 25 respondents. So, ito yung kanilang data na nahanap. This is an example again of test of significance kasi meron siyang tatlong type of music at gusto niyang malaman kung ano yung preferred na music type among millennials. The reported average family size is 3.18. A random sample of 24 families from a certain community was surveyed regarding their family sizes. The researcher aims to determine if the average family size in this community differs significantly from the national average, with a significance level set at 0.05. Again, this is an example of test of significance kasi gusto niyang malaman, okay, kung yung makukuha ba niyang average size from the sample of 24 families is different from the national average family size. So now you know na kung ano ang pagkakaiba ng estimation and test of significance. Going back to our example number 1, so sinasabi natin dito na 38% out of the 150 na samples claimed to be ready for remote learning. And we are estimating now the population proportion using the sample proportion. And this is an example of what we call a point estimate. Ano nga ba ang point estimate? A point estimate is a specific numerical value estimate of a parameter. Meaning, ito yung estimate na exact number talaga yung ibibigay sa'yo. It can be in form of a percentage, a fraction, an integer, okay, or anything, basta number, specific number siya. So for example, given tayo ng sample at gusto nilang ipa-estimate kung ano yung value ng population parameter natin, we will use the following. So kung ang pinapa-estimate sa'yo ay population mean, you will use the sample mean. Kung ang pinapa-estimate sa'yo ay yung population proportion, gamitin mo yung sample proportion. Kung pinapa-estimate yung population standard deviation, gamitin mo yung sample standard deviation. At kung pinapa-estimate yung population correlation, gamitin mo yung sample correlation. The scores of randomly selected grade 9 students in a statistics quiz are shown below. Estimate the population mean and population standard deviation of the scores in the statistics quiz for grade 9 students. Since ang pinapa-estimate is yung population mean at population standard deviation, gagamitin natin yung sample mean and the sample standard deviation. An output from the movie shows that the sample mean is 36.64 and the standard deviation is 7.11. Therefore, the population mean is estimated as 36.64, and the population standard deviation is estimated as 7.11. A researcher asked respondents if they are in favor of purchasing the COVID-19 vaccine. Out of the 540 respondents, 385 favored purchasing the COVID-19 vaccines. Let's estimate the population proportion of individuals who are in favor of purchasing the COVID-19 vaccine. So since population proportion yung pinapa-estimate, we will use the sample proportion. And we found out that the population proportion is estimated as 385 over 540 or 71.30% are in favor of purchasing the COVID-19 vaccine. Another form of estimation is what we call the interval estimation. It is a range of values used to estimate a parameter which may or may not contain the actual value of the parameter being estimated. So dito, instead of a specific numerical value, this is now a range of values. Kaya nga interval estimate eh. There is an interval. The mean weight of grade 9 female students was approximately 48.4 kilograms to 49.8 kilograms, or that is 49.1 kilograms plus or minus 0.7 kilogram. So this is an example of an interval estimate. Sa mga susunod na topics natin, you will learn kung paano gumawa ng isang interval estimate. Now that we know our estimates, ano nga ba ang properties ng isang good estimator? First, dapat impartial. Second, dapat consistent. And third, dapat efficient. First property, the estimator should be unbiased, meaning that the expected value or mean of the estimates obtained from the samples of a given size equals the parameter being estimated. Property 1 is associated with the mean of sampling distribution of the samples. When this mean equals to the parameter being estimated, then we can say that the estimator is unbiased. Second property is the estimator should be consistent, meaning that as the sample size increases, the value of the estimator approaches the value of the parameter being estimated. Di ba nakita ninyo yan nung gumawa tayo ng mga simulations sa sampling distribution? Property 2 utilizes the law of large numbers. Habang pinaparami mo yung observations or samples mo, yung value ng estimator mo, lumalapit siya doon sa value ng parameter being estimated. The last property is that the estimator should be relatively efficient. This implies that among all statistics available for estimating a parameter, it possesses the smallest variance. Itong property 3 indicates that an efficient estimator yields increasingly accurate estimates as the number size grows. So parang sa ginawa nyo sa sampling distribution noon, habang pinapalaki mo yung sample size mo, yung variance or yung standard deviation from the true parameter, lumiliit din siya.